Okay, let's get started. We're ready? We're finishing week 11. We're finishing week 11. That gives us week 12, 13, and 14. 2, 4, 6 meetings after today is all we got left. 6 times is all I got to try to mold you into professional human beings. It seems impossible. What? Let's see. Did I just record that? Sorry. It does. All right. Oh, look at I put a date and a time for the final exam on the schedule. And it's, if you hit syllabus on Canvas, you'll see it there, and it's right here. Your final exam is on the 25th. Your last class is on the 18th. So I'm assuming that some of your other finals are going to be between our last class on the 18th and a week later on the 25th. There's only one more day past the 25th where there's finals, like the 26th, I think. So we're right towards the end. This will probably be one of your last finals. In here at 11:30. There's finals going on at 9 o'clock to 11, and so that gives those people a half hour to grab some food or whatever, and then there's 11:30 here. Remember, no matter if you, a lot of people, every semester I get, oh, your final exams at the same time as another class. That's impossible. They schedule almost impossible. They schedule these so that they don't overlap on purpose, and that's why we're starting at a weird time, so we don't overlap with that morning class that usually takes place on Tuesdays. But we're at the 25th at 11:30. So now you know exactly what it is. We meet 6 times after today, and then it's the final. That's all we got. When we already did a review, so there's not a review coming, just so you know, we did a review already. We talked in length about binomial, Poisson, exponential, and normal. But this week we go heavy into normal with sample sizes, and next week we go heavy into proportions, which we have not learned yet. The week after that, it's all about confidence intervals, and then we do quality control on the last week, week 14. All right, so now let's talk about this week again. Let's go back to the instructions. You got 1 page of assignment. That assignment happens to be both your written and your Excel portion of your assignment. You need to write Excel equations on each of these. So let me show it to you. You have 6 problems with an A and a B. Every A is about using this equation right here and that equation with it. Let me repeat that. Every A, so you have 6 A's there. You should have a manual calculation of Z with norm S distribution finding the probability instead of using a Z-chart. Let me repeat that. The homework has 6 A's, and all the A's are manually calculating Z with the new standard error on the denominator. Then you take that result, plug it into norm S distribution, and put the result down. Those are 6 of the A's. The B's are all about using this equation, norm.dist. All 6 B's. And the difference this week is that third number right there. That third number's got to be the standard error now, not the standard deviation. The standard error. And there's always a 1 on the end, of course. The only thing you got to worry about is, if this is a more than question, you need a 1 minus in front of your norm S, and you need a 1 minus in front of your norm.dist. That's the only weird part you're going to have. There's none of this thinking about, oh, what's the opposite goes here or anything like that. You should have your homework done by the end of this lecture today. That's how easy it is. Rick Holt, he's almost done with it because I challenged him to be done with it. But it was supposed to be before class started. He didn't make it. But that's beside the point. It's that easy. It's just a repeat of this. Now, there is a problem in here that gets a little tricky because it uses negatives. Let me jump down. Which one is it here? Number 3. Is that the one you skipped? Was number 3? Is that the one? Let's talk about it. It says there's a random sample of 36 taken from a population mean of -42, the standard deviation of 9.5. Show your detailed work manually calculating z-score, then give your norm S distribution equation and result to find the probability the sample mean will be a -40 greater than negative 41. So this is negative 41 or more. You do not do anything different just because you have negatives than you would do if these were positive numbers. So here's the big hint right now. I'm gonna do the numerator, because this is where everybody questions themselves. Am I doing the numerator right? It's always what you're being asked about, which happens to be negative 41, minus the mean, which happens to be negative 42. So let me show you what I just did. Negative 41 minus negative 42, when you got minus minus, that means you're going to add. So this is really going to turn into negative 41 plus 42, which then turns into, what does that turn into? 1. Right? Does that look right? So I just did the numerator part, just the numerator. I didn't do this whole problem. I just did the numerator because that's the part where everybody questions. Hopefully that helped. Look, it's gone. Gone. I don't even know what I just said. I don't even know what you're looking at. Not even there. You have 6 on here, I believe. 4, 5, 6 A's and 6 B's. There was one more with negatives. I believe it's number 5. You had no problem with number 5, even though that was negatives?
No, it was the more than.
Oh, it's because it was more than. Okay. Okay. So now, where do we start today? I think I'm gonna start right here. Just, oh, wait. So you got the homework figured out. You know what's due Thursday before you get here. We have a short lecture, so I have some filler information here. Let me know when we're in a lull. And then I'll call the audible from the coach's line. They'll then throw in this audible financial information for all investors, future investors. So, let me start with this example right here. Can we see it? Maybe I gotta zoom in. This example is all about you focusing on the new denominator. This right here, we're gonna call it the standard error. Standard error. The new denominator, this is what we're focusing on. It says, the chefs at a local pizza chain in Cambria, California, strive to maintain the suggested size of 16-inch pizzas. There it is, 16-inch pizza. That's what the pizza is supposed to be in diameter, 16 inches. Despite the best efforts, they are unable to make every pizza exactly 16 inches. The managers determined that the size of pizza is normally distributed with a mean of 16 inches and a standard deviation of 0.8. So here we go. 16, 0.8 is the standard deviation. That's what we know. A, what's the expected value and the standard error of the sample mean derived from a random sample of 2? The sample size now is 2. The word expected value is no different than asking for the mean. So this 16, there's your expected value. Every piece is expected to be 16 inches in diameter. But the standard error is what we're learning how to calculate now. The given standard deviation, which was 0.8, over the square root of 2. There it is, 0.8 over the square root of 2, which is right down here, right where my pointer's at right now. 0.8 divided by the square root of 2 is 0.57. That would be the denominator part of the equation from now on, as far as how you do this, to find z, because now we have sample sizes of 2, 4, 30, 49, 64, 100, and so on. Look at B. It says, what's the expected value of the standard error derived from a random sample of 4 pizzas? Nothing changes. 16 is still the expected value because that's what we expect the pizza to be. That's the mean. But instead of 0.8 over the square root of 2, it's 0.8 over the square root of 4. That's the only thing that's changed because now the sample size is 4 pizzas in B. That's it. So the main thing I'm trying to get across here is this is the new denominator. All about you looking in the question as to how many the sample size is. Because all of these questions on the homework have sample sizes involved now. All right, so now, where are we going here? We're going to, let's do one. I want to do it all the way though, from beginning to end. So we're going right here. Come on. Oh, there we go. All right, here we go. Let me make space here. I'm not gonna calculate this all the way to Z. Today's all about, we're gonna set this all up as far as the manual equation is concerned for each one of these questions. Then we'll have, we know we gotta use norm S. Matter of fact, let's talk about norm S before we do this real quick. I wanna make sure everybody remembers how to do norm S. Let's get that on there. Just to refresh your memory, norm S distribution replaces looking up on the Z chart. So when we manually calculate Z, which is now this equation, what it's doing, whatever the result is, it's placed in the parentheses. So as you can see, if Z calculated it out to be a 2, and the question was about whatever the numbers are, blanky blank or less, then we would have equals norm S dist, parenthesis, 2, parenthesis. And it would look on the Z chart and say 0.9775. If the question was something, instead it was asking what's the probability of this number or more, all we would do, and we calculate it out to be a 2, we would then put 1 minus normal S distribution, parenthesis, 2, parenthesis. So all we're doing is replacing looking up on the Z chart with this equation. But don't forget, every one of the A's, you're showing your work to calculate the Z, you're then giving this equation with that Z in the parentheses, and then you're giving me the result because you entered it into an Excel spreadsheet. And if it happens to be more than, you need to make sure that 1 minus is in front that you wrote down on that norm S. So now, we're all refreshed how to use norm S. Let's go back. Again. Whoop. Okay. Here we go. So we're using the information about the 16-inch pizza, and don't forget, let's talk about this information right here. I'm going to set this up. It says, what's the probability that a randomly selected pizza? I don't even want to talk about that one. That's a sample of 1. All our homework's about samples more than 1. So let's go straight to B. What's the probability that 2 randomly selected pizzas will have an average diameter less than 15.5 inches? There's the question. You ready? 15.5. I want to make sure you see this. This black is not dark enough. Hang on. I'm noticing on the video you can barely see these unless I write really dark. 15.5 minus the mean 16 over 0.8 divided by the square root of 2. I'm putting parentheses around that because we do our numerator, we do our denominator, then we divide last. So like I said, I'm not going to calculate this all the way out unless it's this easy. Negative 0.5 is our numerator, denominator, whatever that turns into. The answer's on the next page if we want to look at it. Let's pretend this Z comes out to be whatever. That goes here now. Now you would write equals norm S distribution Z. Can't see the calculator, but I'm going to go ahead and do this. What is the square root of 2? 2. I know you can't see the calculator, but 1.4142 is the square root. Now I'm going to take 0.8 divided by the square root of 2, divided by square root of 2. Equals. So our denominator is 0.5657. 0.5657 is our denominator. So now we end up with -5, the negative 0.5 over 0.5657. So negative 0.5 divided by 0.5657. Here's our Z. This is the only Z we're going to calculate though. The rest of them we're not going to do. Negative equals negative 0.88. Anybody else do that?
Yes.
Same thing? Thank you. I'm going to do 2 more decimals, but we got to go 4 decimals. So 39. is what I get, depending on where you round it. There it is. Now, this equation, if you're doing your homework, there's the manual calculation of z. You now take that and you go equals norm S dist parenthesis negative 0.8839 equals. You're doing this one all the way to completion. So you can see how we do it. So now I'm going to Excel, and I'm going to go right here on the same spreadsheet. I'm going to go right here. Equals norm S dist parenthesis. What was our z? Negative 0.8839. I didn't put a 1 minus in front because this isn't asking about two 15.5 inches or more. It says 15.5 inches or less. What's the probability that it will be less than 15.5 inches? So there's no 1 minus in front. Here we go. Negative 0.8839. The probability, if we were to look on the Z chart, is, there it is, 0.188, let me write it down. This equals 0.188, is that 375? 375. Now, let's do let's do B now. There's A, A's done. Manually showed our work to get to Z, including showing what the numerator calculated out, the denominator. All of you who keep losing that 1 or 2 points because you didn't show this little work, make sure you're showing it. Then what that calculates out to, we plug it into our norm S distribution, we got the result. When we do this, the result should be darn close to the same result we just got here, or we made a mistake somewhere along the way. So now we're going to do right here, ready? Equals norm dot dist, parenthesis. We're asking about what's the probability of 15.5 inches or less, so I'm putting 15.5, comma. The mean diameter of the pizza should be about 16 inches, comma. Now here's the part that's different. We're not putting just the standard deviation here. We're putting the standard deviation over the square root of the number in the sample, which happens to be 2. But we got to remember to use SQRT in this. Now, if you decide you calculate this and you just want to enter 0.5657 there for the third number, I'll accept that, but I have to see the work somewhere on B that you calculated that denominator to put in there. Go ahead.
That's what I was going to ask you. Already, if it was in A already.
It is an A, but just kind of, or at least take an arrow and point it up to A and show me that you got this from there if you want to just enter that. But I'm telling you, you're rounding here 4 digits, you'll get a more exact answer if you just put the whole denominator in there, which is what I'm going to do right now. Are you ready? 8 divided by SQRT parenthesis. How many sample size? 2. And now the last thing, put comma, put a 1 on the end. You always put a 1 on the end for normal. You always put a 1 on the end for exponential. Parenthesis. All right, now if I did this right, it should be darn close to that 0.188375. Here we go. Oh, what did I do wrong? Oh, it's not 8, it's 0.8? Oh, you guys had that straight look in your face and didn't speak up until after? Okay, here we go. Look at the result. Darn close. Now the one on the right is more exact because the one on the left has us rounding our result. This really went more than digits in this, and we rounded back here also. So these two roundings cause that to be slightly off, but I can tell you, those are so close to each other that you know they're practically the same. And you know you did it right. You know you did it right. It's a good check and balance. All right, let's do another. Let me go here on this one. I'm going to try to refresh your memory. This is, you're working at the college, you're the admissions director, you just got called to meeting and started to sound familiar. You got to bring the SAT scores, the average SAT. You don't have these, how many? 900 applications of acceptance. There's been more applications, but we got it narrowed down to 900. These are the 900 being accepted. We haven't got it in the system yet. We had to pick 30 at random. Let me erase this. We got numbers we're talking about here. Hang on. Hang on. Okay, hang on, right here, right here, right here. Get rid of this, we don't get confused. Here we go, we have our SAT scores. We already know what the sample size is because we drew 30 random numbers to select 30 out of the 900, if I recall. And, let's see, where was the real score? There's what we got. Hang on. Here's the actual, if we recall. On the left is the actual, on the right is what our sample got us. What we're going to do is say, okay, we know now that this is 990. We want to see what's the probability that we could have done that with a sample size. Oh, by the way, what was the standard deviation? 80? 80. There we go. Here's the question, all right? Now that we know what was the probability that we walked into that meeting and we could have accidentally had a score of, let me find something kind of ridiculous, let's say 980 or less. Or less. What's the probability that we could have walked into with a score that's more than 10 under the real score? So we took a chance with a sample size of over 30. And we want to see what that chance was. Here we go. There it is. There's the setup. Here's the question. I'm going to say it again. The average SAT score of the 900 incoming freshmen is 990 with a standard deviation of 80. We went ahead and got a sample size of 30. What's the probability we could have walked into that meeting with a sample mean of 980 or less? There it is. 980 minus the mean, 990, divided by 80 is the standard deviation over the square root of 30. Whatever that equals, we would plug it in for Z right here and get that result. But let's talk about this. What's my X? Help me out now. What's my X? 980. What's my mean? 990. Very good. Now, here is where you're going to put 80 over SQRT, parentheses, 30, parentheses. Sample size of 30, comma, 1. That's it, right there. That will give you the probability. Let's do it. I'm just going to go to this one we did already. I'm going to switch the numbers. So here it was 980 or less. Right? Right here, again. And the mean is 990. The standard deviation is 80 over the square root of a sample size of 30. 1. How's it look? Up at the top in that window up there. I have it? Go ahead, Autumn.
Yeah, you always use 1, right?
Always use 1 for normal distribution and exponential. Always a 1 on the end for exponential and normal distribution. It's binomial distribution of Poisson that could be a 1 or a 0. But for normal and exponential, always a 1 on the end. All right. Before I hit enter, if we did this right, I want to show you something on this PowerPoint. Here's the same question. Here's our standard error, 80 over the square root of 30 right there. It says, what's the probability of, let's say, 980 or less? So we took, no, that's not the 980. Let's get to the 980. There it is. 980 minus 990 divided by, that is 80 over the square root of 30, which equals 14.4, equals a Z of negative 0.68. We look up negative 0.68 on the Z chart, 0.2485. So what I'm saying is that this is saying that there's about a 25% chance we could have walked into that meeting with a score that was more than 10 points below the real average. Let's see if what is that, about 0.2483. Let's go back to Excel now. If I hit enter here and we did this right, it should be about 0.2483. Look at that, 0.2468. Almost 25%. These are too easy. You got your homework done yet? Should I keep going? Oh, my grandmother would be done. She's passed away, but she would be done. I'd bring her in here. Prove it. All right, let's do another example. I gotta think, where's the next example I want to show you? Here we go. Let's go over here. We're gonna go to page 257. Is that where we're going? Two fifty. 250. Example 7.4. Oh, here's another one. All right, let's look at this one. Let's set this one up. Okay, be ready. I'm going to ask you to help me set this up this time. All the numbers. Hang on, let me erase these. Let me get this all erased. Can we see it? We're going to talk about, no, we're going to talk about this one. Right here. Now look at the solution. And block as much of the solution as I can. Help me out. This is something minus something over something divided by the square root of something. Consider the information presented in the introductory of this chapter. This is Camelia wants to determine happy hour promotion for lingering effect, amount of money customers spend on iced coffee. This is at Starbucks. So the average amount of money spent on iced coffee is what this is all about. And it says, before the manager did a promotion, customers on average spent $4.18 on iced coffee with a standard deviation of 84 cents. Let me repeat that. Before the promotion took place, we went ahead and looked at details of when everybody's using their credit card, everything's entered in the computer so we can see what the average amount the customer spends per, is it per week? I don't know if it's per week, but does it say week? Doesn't say? Darn. It says before the promotion, customers spent an average of $4.18 on iced coffee with a standard deviation of 84 cents. Now the manager reports that the average amount based on a sample of 50 customers after doing a marketing campaign found the average to be $4.26. What's the probability that the marketing campaign, or after a marketing campaign, that the manager would find a result of $4.26 or more when usually customers only spend $4.18? If that result, by the way, of getting $4.26 or more is really low probability of happening, that gives you evidence to say, hey, the marketing campaign is what made that people have a higher average spend on iced coffee. Instead of maybe just, oh, it's just luck that those 50 customers happen to have a different average. So let's see what that probability is. Help me out. What's our X in this case? What is it we're trying to find the probability of? 4.26. Don't let Lexi be the only one. She always answers the questions for me though, Lexi. Thank you. You're my backup. Okay, now, what is going to be the mean that we use?
4.18.
That's right, $4.18. That's the expected, that's the amount that they spent on average before the campaign. What is going to be my standard deviation down here? 84, that's right, 84 cents over the square root of what?
4.26.
No, 50. 50, how many customers were in the sample? Where did it say? I forgot. There it is, based on 50 customers sampled after the campaign. So there's our setup. I know you guys can do the algebra. Your numerator is going to be subtracting these two, which you're going to get 8 cents. 0.08 is your numerator. Divided by whatever 84 cents is over the square root of 50. Get that number, and there you go. There's the setup. You then calculate your Z. You would put it right in your normal S distribution. What am I forgetting though? I just forgot to do something. What did I just forget? 1 minus, look at that. 1 minus in front, there it is. Because this was $4.26 or more. What's the probability that happened? All right, let's do the norm disk. What's my X? 4 what? 4.26, comma, what's my mean? 4.18, comma, here we go. This is 0.84 over SQRT 50, parentheses 50, comma 1.
On that one, you put one minus. in the-
Oh, thank you, David, look at that. I almost forgot. 1 minus in front. There it is. God, I almost made a mistake twice. All right, I'm just gonna change this up to see what that probability is. I wanna tell you, if we get an answer that's like below 5%, like 0.05 or less, this is how research is done. It's like, look, there's no way luck could have made that average amount go up to 426 out of 50 customers. But if this calculates out to like 10% or 20% or 30%, we don't have evidence proof without a shadow of a doubt that the marketing campaign did it. Because the sample of 50 could have just been luck to have gone up to 426 instead of 418. That's how research is done. Okay, so here's our results before the marketing campaign. Let's randomly pick 50 customers that were part of the results. Boom, we picked them out, and now they're spent an average of 426. What's the probability luck caused that instead of the campaign? Well, I hope this turns out low. Here we go. Instead of 980, we're testing, you guys told me $4.26. The mean was $4.18. Am I correct so far? Is that true? Anybody? Okay, looks true. The standard deviation is 84 cents, 0.84, with a square root of how many in our sample? 50. There we go, and a 1 on the end. So if this is 0.05 or less, oh, I forgot the 1 minus in front. Woo! Could have been awful. There we go. If this is 0.05 or less, we have proof that the campaign caused people to spend more money. Well, considering you can't see it, that was anticlimactic, wasn't it? Why anybody say anything? Leave me hanging? You know we're recording? You left me hanging while we're recording? Oh my God. That's it, class is over. Now you know how to get out early. Oh, hang on, let me show you again, ready? 1 minus normal distribution, 4.26, comma, 4.18, comma, 84 cents over the square root of 50, comma, 1. I hit enter, 25% chance. Now, I know that seems low, but in research, that's not low enough. Luck could have caused the average price in that sample to go up to 426. That's got to be about 5% for you to go look at my research. That promotion, and by the way, marketing majors, this is used often to prove whether a promotion you came up with really was successful or not. Is collecting the data before the promotion, collecting the data after to see if something increased that you wanted to have increased because you put that promotion together. This is exactly how you prove it. And by the way, in a lot of companies that are big, they'll do a promotion in a regional area, get the data to see if the promotion really did take place, and this is how marketing directors then get $1 million budget to now take the campaign nationwide because you proved it had an effect in a region by using statistics. So that's how it works. That's how you get the money. You have to prove that it's really gonna work. You have this concept that you dreamt about accidentally from too much drinking. And now you wanna put it to action, but you gotta prove it will have an effect before you get handed the $1 million. All right, you ready for another one? Let's go to another one. Where are we going here? Let's go back to the book. Is this time to learn how to invest? Are we almost there? No? 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 Okay, just checking. Where are we going next? We're going to page 251, number 9. There it is. Oh, this is a good example to help you with number 3 and number 5 from your homework. Great example. I'm at number 9. Hang on, let me erase. You guys gotta help me with these numbers here. Get ready. Now, get rid of the 1 minus. I don't know if this is a less than or more than. Okay, it says a random sample size of 50 is taken from a population with a mean of negative 9.5. The mean is negative 9.5. Standard deviation of 2. Calculate the expected value. Well, the expected value is negative 9.5. We already know that. And the standard, forget A. B. What's the probability that the sample mean is less than negative 10? So this is less than negative 10, negative 9.5. There's a 2 for the standard deviation. We got sample of 50. Help me set it up. What's the numerator? What's on the left? Negative 10. minus, what's on the right? Parentheses, negative 9.5. So I got negative 10 minus negative 9.5. That's the same as adding 9.5. So when you have negative 10 plus 9.5, you have negative 0.5 left in the numerator. Right? Denominator, tell me what's in the numerator part of the denominator. 2 is the standard deviation. Very good. Over the square root of what? 50. There's the setup. If you can set up these negative numbers just like that, negative 10 minus negative 9.5, and this denominator with the standard deviation and the sample size, I know you guys can all do the algebra. It's just the setup is all I'm worried about. I know you all can do the algebra. Help me with, once we get a z, am I putting a 1 minus in front on this one?
No.
No, because it's said negative 10 or less than negative 10. Help me with the normal dot distribution here. Matter of fact, let's do it right on the calculator so we can get an answer for this one. I gotta switch it back. Wait, do we have these numbers memorized? They're in the problem right there. Okay. Here we go. Help me with the norm S. Get ready. You're saying get rid of the 1 minus in front. Norm DIST. What's the first number? What's X?
Negative.
Negative 10. Negative 10. Let me get rid of the 4 point. There we go. Let me get rid of this. What is the mean? Negative 9.5. Very good. Now I go over here. What is the standard deviation? 2 over the square root of what? What was the square root of what? 50. I just leave it. And a 1 on the end. Okay, when I hit enter, this is going to give us the probability for negative 10 or less, when usually it's negative 9.5 with a standard deviation of 2, and the sample size is 50. Here we go. 0.03855. 0.03855. If we were to calculate this all out and get to our z, and we put z up here in this normal S distribution, we would probably get almost that same answer, 0.03855. These are too easy. Is your homework finished yet, or should I keep going? Your homework's not done yet? Okay, I'm gonna keep going then. I can't stop unless your homework's done. All right, let's see, what are we going to next? Let's go to another one of these. Move this back. What was that, name? B? Let's go to number 10. This time we're going to do them both A and B. Help me set this up. Let me get ready. God, these are too easy, aren't they? Is it just me? According to a survey, high school girls, oh, come on. Can't they just be high school people? I'm going to change it. Here we go. According to a survey, high school, good boys and girls, average 100 text messages daily. Assume that the population standard deviation is 20 text messages. Suppose that we pick a random sample of 50 high school men and women, boys and girls, whatever. A, what's the probability that the sample mean will be more than 105? Start here with my Z calculation. What's my X? Help me out, I can't hear you guys. 105 minus, what's my mean? 100. What's standard deviation? 20 over the square root of what? It sure is 50. There you go, there's the setup. I know our numerator is going to be 5 over 20 over the square root of 50. Whatever we got for Z, we put into norm S distribution. Is there a 1 minus in front in this case?
Yeah.
There is? Does it say more than? Oh, my bad. 1 minus. I didn't think it said that. There you go. Very good, Matt. Good catch. Now we got to put a 1 minus in front of our normal distribution. This one we're doing live though, aren't we? We're going over here. Remember our numbers. 105, 100, 20, and 50 are our 4 numbers. Let's go back to Excel. Right here. Let's just write a whole new equation. Equals 1 minus, I think, norm DIST, parenthesis, our X. Tell me the number. 105, comma, what's our mean? 100, comma, what am I putting on the top here?
20.
Is it 20? 20 divided by SQRT, parentheses, 50 it is, comma, 1, parentheses. Here we go. Here's the probability that usually there's 100 text messages for high school students with a standard deviation of 20 per day. What's the probability of 105 or more? 105 is not that many more than 100. So it seems like the probability would be pretty high. No, it's only 3.8%. 0.038 is the same answer we just got on the problem before it. Isn't that crazy? What the heck? So there's really only a small chance of doing 5 more than the usual. Seems like that's a lower probability than I would have expected. All right, let's do the other one. We're doing B on this one also. Wait, is this 10 or 12? Oh, this is number 10. Okay, we're doing B on this one though still. I realize. We go back here. We go here. You're going to tell me what to change in this problem. B, what's the probability that the sample mean is less than 95? 95 or less. Tell me, what do I have to change in this manual calculation right here? Amen. What do I have to change here in this manual calculation? Ollie. What do I have to change? Somebody. These guys aren't going to listen to me. I have to change the 105 to what? To 95. Ready? 95 or less. 95, not 195. 95 minus 100. The only difference here now, this is a negative 5 on the numerator. So let's do it now. I'm starting to get the feeling this is going to be the same probability because the only thing that changed is we went from 105 on one side to 95 on the other side. So let's take a look and see what effect that has. We'll go here, go back here, put it right here. Equals. This is 95 or less, so I'm not putting a 1 minus, NORM, DIST, parentheses. Our X is now 95 instead of 105, comma, 100's our mean, comma. We're still doing 20 over SQRT 50, comma 1. If I'm correct, parentheses, this should be the same answer, 0.03855, because all we did was go to the 5 the other side. 0.03855. Is our homework done? We're not done yet? Mariana, you done? She's done. If she's done, we're all done. You're not done? You were just bluffing?
Yeah.
Oh, I felt good for a minute. Second. We gotta give you the thespian crown. That was a good one. You're gone. You're out. She just moved. She took it away. You ready? You ready for this? You want a little spice in action? Are you ready? Okay, here we go. Gotta edit this out of the video though. This is just for you guys. Hang on. Woo-hoo! All right, we're back to the fun stuff. You ready? Back to the fun stuff. This is where the video starts as soon as I get back here. All right, we got one more. Go on to page 251. All of you who bought your book, we're gonna do number 12. Okay, get it up here. You ready? We're doing number 12. We'll do A and then decide if we want to do B. So I'm at the bottom of the page there. It says, despite its nutritional value, seafood is only a tiny part of American diet. With the average American eating just 16 pounds, there's one of our numbers. Let me erase this. With the average American eating just 16 pounds of seafood per year, Janice and Nina both work in the seafood industry, and they decide to create their own what? Create their own what? Not all of them. Random samples and document the average seafood diet in their sample. Let the standard deviation of American seafood diet be 5 pounds. What was the average amount they eat? How many? 16, so we already know this is 16, the standard deviation is 5, right? We got 2 of the numbers. Here's A. Janice samples 30 Americans, finds the average seafood consumption to be 18 pounds, how likely is it that the average from her sample would be 18 pounds or more? Here's my X. Tell me the X here. What goes here on the left? No. 18. 18 minus 16 is 2. What's the sample size? Now. 30. Thank you, Stephen. I prompted you. Where were you? Okay, so 2 over 5 over the square root of 30. There's the setup. There it is. Help me out up here though. We gotta have that 1 minus in front of the norm S distribution because this is asking for 18 pounds of seafood or more. And on our norm distribution equation, we also have to have the 1 minus. So here we go. Let me go back here. Remember our numbers. Equals 1 minus, because it's 18 pounds of fish or more per year. 1 minus NORM DIST, parenthesis, 18 pounds, comma, usually it's 16 pounds, comma. Here we go. Standard deviation is 5 pounds over SQRT, sample size of 30, comma 1. Okay, when I hit enter, it says this is going to be the probability of the sample of 30 people, Americans, were eating 18 pounds of seafood per year or more compared to usually 16 pounds with a standard deviation of 5, sample size of 30. The probability of finding that is just barely over 1%. It's pretty rare. So what's happening is there's such a low probability that randomness made that happen that maybe this researcher found something that the average is not 16 pounds, that it's possibly 18 pounds. Because look at how low the probability was of that happening from randomness. That the research is trying to tell us something. It's only a 1% chance that random made that happen. Something else is happening. That 16 may not be the right amount. Now let's look at B real quick, see what B says. Oh wait, yeah, we did already. Okay. There we go. B says, Nina, the other researcher, decided to sample 90 Americans instead of only 30, and finds the average seafood consumption to be 17.5. So watch what has to change up here. I'm changing this 18 to 17.5, and I'm changing the 30 to, how many was in the sample? 90. And what my question is, what I'm curious about is, if I were to calculate this out, is the probability of us getting 17.5 pounds or more, does that say or more? Or more, is the probability of that happening lower or higher than what happened in A with Janice getting 18 pounds with only a sample of 30? Here's what I suspect. The sample size is so much larger in B that even though the mean is 17.5 compared to 16, and it's less than the 18 from A, the probability is probably going to be less because the sample size is so large. Usually the larger your sample size, the closer to your expected value. And we did get closer to the expected value, but we're still pretty far away, 1.5 pounds away still. So let's see if I'm right. I could be wrong. Let's see which researcher is making a point here. They're both making a point probably. So now here's the difference. Here's one researcher, 18 pounds compared to 16 with a sample size of 30. Now we're going to do the other one. Equals 1 minus norm DIST parentheses 17.5. Thank you, dude. Look at your kitchen. Comma. We're expecting 16 pounds. Comma. Standard deviation of 5 pounds over SQRT. How many is the sample size? 90 in this one. Comma 1. If this probability is less than 0.01423, this researcher with the large sample size is even making more of a point that there's no way 16 could be. But if this turns out to be like 5% or higher, this researcher is not making a point at all. That could be randomness that made it happen. Let's see. Wow, less than 1%. It's 0.2%. It's not even a 0.5%, 0.2%. So this second researcher is making a very big point saying there's no way the average American's seafood consumption can be 16 pounds a year when we have two researchers that found significant results that it's more than 16 pounds. With a sample size of 90, got 17.5. With a sample size of 30, got 18. Both of them are trying to say, hey, the average consumption is really not 16, and that's how research is done. Because the odds of randomness causing these results are so small that it was something other than just randomness, that truly this cannot be right, that this is wrong, because we keep getting such a large number compared to it with such a large sample size. That's it. That's your homework, all in a nutshell. Every one of you should have it done within 10 minutes.